So I'm going to pick a side as my bottom side, and it's not going to be one of the circle sides. I'm going to pick, just out of convention, purple. So I'm going to gear it up to where I'm going to find the purple and orange, purple and white. So purple and white is already here. Purple and orange is here, so I'm going to stick that opposite. So that's in line here. And then I have the purple and red. Find the purple and orange. And the purple and orange is probably right under my nose. Probably past it if you, there it is, purple and orange. So I'm just going to move that into configuration right there. So here's a nice little cross, and then just keeping in mind the sides you can't turn and the sides that you can turn, just fill in the rest of the corners. So here's the purple and red. Purple and red is here. Purple, red, and white. So this is going to end up over here. I can't move it over from here, so I'm going to go down and up. And really just very intuitively put the purple sides where they're supposed to go. Or the purple corners up here where they're supposed to go. So red, purple. Okay, so picking up where we left off there, basically you have the first layer, so to speak. You've got the side, and then you've got your cross over here, which is what you need. Now you want to fill in these middle pieces, and just like a 3x3, you start up here and you see what needs to move into place. Here's the red. This needs to move down here. Now normally in a regular Rubik's Cube, this would come back and this would come up, but you can't do it. So you have to modify the algorithm just a little bit. It really isn't much of an algorithm that you have to worry about. You can just sort of play around with it, but if time is of the essence and you want to get fast at it, then in the side that you can move, if it's on the right side that you're using, to move this down here, you can use the algorithm R, UI, RI, UI, R, UI, RI, U, R, U, RI. And that gets it where it needs to be. And literally that's just like fiddling around with it. Same thing here, this needs to come down here. So you do that same algorithm, R, UI, RI, UI, R, UI, RI, U, R, oops, U, RI. So that's where it needs to be. This we gotta pop out of here because it's the last one left and it's disconfigured. So just pop it out in any way that you want. Okay, so that was a laborious process, but anyway, we want to move this into place here. So doing it from the left side, same process, only opposite using left. So in this case, it's going to be L-I, U, L, U, L-I, U, L, U-I, L-I, U-I, L. So you've almost got your second layer. This just needs to come into position over here. And this is on the right side. Oh, can't do that there, so we're going to put that here. Same thing on the left side. L-I, U, L, U, L-I, U, L, U-I, L-I, U-I, L. So now you have your second layer. So the next step is to solve our last layer. So as you know, we need our cross, and our cross is always there. If you follow this, the cross will always already be there. So you want to get, your top cross. So now you want to get this part, these in line. So normally you'd see something like this, so you'd apply the algorithm to get on this side, but you can't move this side. So ultimately, you need one of these circle areas solved. So you have it over here. And that's where it needs to be also. So normally this would come here and you'd apply that algorithm, but you can't. So you have to do some flipping around. So I'm going to come here and I'm just going to reconfigure it to try to maybe move this into position, try to move this into proper position. So just flip these center pieces around. Got the same algorithms used for a 3x3. Okay, so I'm going to put this in position and I'm going to try to put this in position. Just like a normal 3x3, not there yet. And that's in position, but these two aren't. So I'm going to try it from this perspective. That is. So if you just keep plugging and chugging, you'll eventually get them where they need to be. Now it's a matter of moving these corner pieces back in. And again, you're free to kind of play around with it. Just keep in mind, this is all you can move, these two layers here. So it's no sense in getting this solved and getting these in position because you can't move from here. So you got to get these in position. So this isn't, and this is. So this is where we want it to be. So I want to get all these in position just by holding this where it is and moving it around. Now if these weren't in position, then you want to move these to this side, flip these around until you get one of these guys in position. By these I mean something where you can actually move a side as opposed to, move the R side as opposed to having these in configuration with the R side. So I'm just going to do the same algorithm as with a 3x3. So this is where it needs to be. This is not where it needs to be, so let's keep going. Where it needs to be, where it needs to be, where it needs to be. So basically it's where it needs to be. So now it's just a matter of doing the same thing. Keeping in mind this has to be your axis of rotation. It can't be here, so you just do it the same way that you did your 3x3. I am not good at finger tricks, and I'm not going to pretend like I am. So you could probably do it a lot faster than me at this point. And just like a regular 3x3, and with all the faith that comes with these algorithms, you'll find that it's solved. And so that's how you solve your WitEden, and that's how you pronounce it, 3x3 circle cube.